Hello, friends. This is the fifth part, which is for designing and building the software product. And we have seen so far how to get the requirements and then how to think about the high level design and then creating the user interfaces and then the middle layer and finally now we need to think about designing the database. So because it's a database connected application, and database is a vital part, and you must have a good design so that the data created should be there in the database, and it should be accessed to see any transactions, right? So let us start. So the first thing to design a database involves creating the entity relationship diagram, which is known as ER diagram also. So for both OBAS 1.1 and 1.2, actually only one design will be enough. It will take care of both. Like you don't need to design differently. That most of the functions are the same. Some slight differences are there, but they can be managed at the user interface and at the business logic layer. And the changes in the database is not required. Only thing is the creation of data will be different for these two entities, and they it will be not something which will impact the design. So instead of wasting time, it is better to just have one design for both the application. So that is why we will discuss only one design. So from the perspective of the user requirements, again, actually, we need to think about the user requirements to build the database design. So we saw that there are users, and so user is the most important entity which should be used in the database design. So there is a user, and for it, in the class diagram also we saw there should be a username, a password, a mobile number, address of the user which need to be saved, right? So these are attributes of the user, the four attributes of username, password, mobile number, address. So one entity and four attributes, and then user has account. Any user has account. So the next entity is account. So account has attributes like account balance and account number. Actually, we will be creating account number for each user. So account number is the attribute of the account. Then the one important thing is user performs transactions, right? So what kind of transactions the user is performing? So we have transactions like open an account for the user, then closing an account for the user, and money transfer by the user from own account to some other account, then bill payment by the user, and service request by the user. So this is the combined functionality, like the changes. Let me discuss the changes between 1.1 and 1.2 versions of OBAS. Uh, in the 1.1 version, we have user account and transactions. Transactions include open account, close account, bill payment, service request. So these are the uh, things required in 1.1 OBAS. In 1.2, there is additional function that of money transfer. So the user will be also able to do transactions related to money transfer. So this is the additional field. And for service request, actually in the 1.2 version, there is a fee. So that fee will be paid when you are doing transaction. So From top level, there is no difference regarding the service request between these two versions of OBAS. So from here we can see that we need to have these entities and we need to create database and so that we should be able to write something in the database or do any modification in any data or delete some data. So from ER diagram perspective, this is all we need. Uh, this ER diagram will take care of all the database requirements. And I guess from this ER diagram you can see it is not very difficult to visualize because from the user requirements it is very much clear what we need to what kind of data should be generated and what kind of data needs to be viewed, etc. So based on the ER diagram, the schema and database entities have been created. Even though there are many types of transactions being done in OBAS, some of them are similar in nature. For example, bill payment and transfer fund transactions are very similar. In both these transactions, fund transfer happens from one account into another account. In case of bill payment, fund transfer happens from the user account to the account of the biller. So, one consideration about that transactions which are done in OBAS is bill payment and transfer fund transactions are very similar. So generally, the same functionality is needed and same kind of data will be involved, right? Like you need two bank accounts, and there should be a money transfer, and then there should be a debit in one account and credit in one account, right? So these are very similar. Transactions such as close account, transfer funds, bill payment, and balance inquiry exclusively deal with the account entity. So the account entity is dealing with close account, transfer fund, bill payment, and balance inquiry. However, service request transaction deals with a service entity. But in case of service request, the entity which get impacted is service. Thus, we can see that for our purpose, only two tables are needed. One table deals with the user and account entities, and the other table keeps information about the service request. So, from the ER diagram, now the and taking things into account, these considerations like these kind of transactions, what we need is how many tables we need to create. So uh, here actually the service request transaction is dealing with the service entity, and all others like they are dealing with user and account. So we need to create two tables, the one for the account connected to the user and doing the all those transactions, and the other one is just to create a service like when a service is needed, then a service request is raised and it has to be tracked, so you need to create a transaction number for any service created, right? So based on this information, we have let us create see how the tables will be created. So for account and user, the new account table has been created. So we are creating new account where these two entities are involved and different kind of transactions are done. So the table new account, the design of this table is we need to create the account number information and it will be of number type. Then we need to take username field which should be of character, and since we are using Oracle, so the variable type is varchar2, and length we have set as 40. 40 is more than enough to keep any username. Then for password field again, varchar2 type, and again 40 is the length. Then repassword type. So again we are setting as 40, varchar2 40 variable type. And then amount. What amount generally will be used, transferred or paid, or fee payment, etc. So the amount field will take care of all those needs, and it should be a number. Then address. So address again, address should is generally long, like you need to provide some street number or street address, and some apartment number, and then city and country, state, zip code, etc. So we have set as 400 characters long. Then there is a phone field, and it should be a number. And then category, because this system is will be used by some administrator also and the users. So for to segregate these two kind of users, we need to keep a category field, and we are just providing one value like U for the user, or A for say administrator. So only one character. So varchar2 of length 1. And we have a constraint primary key, which we actually we will be setting a primary key on the account number field. So the account number field, which will keep account number of uh, each account, user account in the bank. So we have set it as a primary key. Okay, so this was the account, keep taking care of account, user, and some transactions. Okay, and the other table which we will create is for service request. So taking care of service request, a table named checkbook has been created. So the to create it, we have used this SQL to create table checkbook, and the fields here are account number. So this account number is same as the account number in the new account. So in the new account table, account number is will be linked to this account number in the checkbook. So checkbook uh, issued to which account number or which user can be tracked. Then we will be generating a service number. So service number, so that we know which service request is in which state. So, and then service type. So currently we have only service one service type of new checkbook request, but in future there will be more service types. Now, one entity which we need to create is, we need numbers to generate for populating the columns of account number and service number. Okay, so we will create one uh, sequence, and from there we can take numbers and populate both. Actually we can create two sequences, one for service number, generating data for service number field, and another one for account number. But one field can also do, because at this stage this application is just for demonstration purpose and to understand. So we do not want to complicate, and since one sequence will be fine for both, so we will be creating the sequence to populate data in the fields account number and service number. So create sequence, and the syntax is generally create sequence and then sequence name, and then you provide the minimum value. So we are providing minimum value 1, and max value of length 3, 3, 6, 3, 9, 12, 12 digits long number. So maximum value is 9999 up to 12 digits. So it's a long enough number. Actually, you can even keep it shorter than this because it will be enough. But it is fine if you keep a 12 digit number. And then we want to increment each number by one. So the first number generated say is 5. Since in our case we are generating minimum value 1. So for 1 will be the first number and the next number will be 2. The next number will be 3, 4, 5, 6 likewise. And then we are starting with 1. So minimum value is the same as starting value, and then we will not keep any cash. We are not keeping any cash means sometimes you want to keep some cash which you can specify, and that number you can use later, like cash can be used for say generating the service number differently than generating the number for account number column. But we are not bothered right now, so no cash. Then no order, and we do not want any ordering like it should start from top to uh, bottom or bottom to top. So no order. It will just create numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, something like that. And we don't want any cycle, so no cycle. If you want to recycle, like say after you reach this maximum number, and then after that, if you say specify that recycle, in that case, the system will again start generating from one after reaching that maximum number. So uh, that is how it works. But we do not want that, so no cycle. So we will not cycle the numbers again once they are generated. Table new account is the main table in the OVAS database, and it holds most of the data used in OVAS. It holds the information for username, password, phone number, address, and account number. In OVAS at present, we are creating a service number whenever a checkbook is issued. We are using service number column of checkbook table to populate the service numbers. For these services, we have currently created a table checkbook. It is named so because currently there is only one service, that is checkbook issue. In future, when other services are introduced, this table name may need to be changed, and that we can take care of using refactoring. In future, there could be many services introduced by the bank. So we have created a service type field. So currently there is a service type field. So if the bank introduces new services like certificate of deposit scheme, or some uh, some other kind of investment proposals, or say mutual fund attached to the account, uh, or any even like say uh, say the bank will now offer you say new type of accounting, new type of accounts. So those services may need to be tracked. So service type field is already there. So uh, it is not a problem. The checkbook table is transaction table. The account number field in this table is actually a foreign key, and the corresponding primary key is the account number column of the new account table. We have not defined a primary key foreign key relationship between these two tables. This is because once a service number is generated, it is only shown if needed. That is, it does not need to be modified or deleted. For such a scenario, a foreign key is not needed. So in the service table, like the checkbook table, uh, uh, we can define a foreign key. but we currently we are not using a foreign key because we will not be doing any editing of data in this table. Otherwise, if that was required, like you need to edit some data in this table, in that case, foreign key is a must, because the foreign key will ensure that if you are making any changes here, it must be reflected in the primary key. Like the primary key will ensure that if some data is not matching, if there is no master key or master data for a record in this table, which has the foreign key, then it will not allow. So that is the advantage of keeping a foreign key. But since we are not using any kind of editing in this table, so that is fine for not having any foreign key. As per the software requirement specifications, there are no reports to be shown for the transactions. For example, the SRS does not mention the transaction history reports for the customers. So we are not generating any transaction number for the transactions, including the money transfer and bill payments transactions when they happen. Thus, in the database, we have not provided any columns to keep these transaction numbers. So we are not generating a transaction number for the money transfer or bill payment uh, or any kind of transaction. Currently, we are not maintaining, because uh, as per the SRS, we are not required to generate any reports where you can see the history of transaction, or you need to track transaction later, like you want to revert back, or you want to find out about some transaction which was done some time back. So currently we are not bothered, so we are not generating a transaction number. Database transactions such as insert, update, and delete have been used in OBS when users interact with it. So, so far we have shown you the design of the database, like the creation, and then when it is OBS system is used, then data will be created. So there will be insert, update, delete operations will happen in the database as well, because from the users, like the user wants to close his or her account. In that case, a delete operation will happen, or then addition also, all the time there will be transactions, like some uh, bill payment or money transfer or new checkbook request, etc., etc., will keep happening. Similarly, new users will be created. So they will be these will be insert, update, or delete transactions in the database. So, for example, when the user wants to create a new account in Avast, then an insert operation takes place in the new account table, so that a new record can be created in this table for the user. Similarly, when the user wants to pay a bill, then the new account table gets updated. The biller's account is credited and the user's account is debited by the amount of the bill which needs to be paid. So this was about the database design and creation. So next, we will move over to implementing all the design which we have seen so far. So, and I will show you creation of the database, the actual creation. Then I will show you the user interface design, and then I will show you the business logic, how it is written, and finally I will show you how the system is running, and I will also show you some things which need to be taken care of during testing, like if there is any dead code in the system, or if some function is working fine or not. So testing will also be shown. So all of these will be very interesting because we will be doing everything hands-on. So from now on, we will have hands-on sessions, and it will be very interesting for you to see in a live environment how these things are done. So thanks for your time, and bye for now.